Okay, so right now we have the graph of sine of x. Okay, so it's the one I did in the notes. It's the one we created the table for, so that's the graph in front of you. Okay, so looking at the graph, there's a couple of vocabulary words we're going to use with graph. Now we've done a lot of graphing this year, but some of the words, some of the vocabulary is different. So the first one is amplitude and periods. Okay, what amplitude is the kind of the height of the graph. Okay, so when we're talking about the height is how high from the beginning, from the very beginning of the graph. So the very beginning is 0, 0 here. How high does it go up and how high does it go down? So this graph went up 1 unit and then it went down to 1 unit. So it never goes above 1, it never goes below 1. So that is going to have an amplitude of 1. Another way of finding it is A here. Okay, so we've kind of dealt with this before. A, B, C, and D. A is the amplitude. So the easy way of finding the amplitude is the absolute value of A. Okay, so this has an A of 1. So this guy would have an amplitude of 1. Okay, it goes up to 1, down to -1. Okay, a period. So the period is pretty much how long it takes for a graph to go through one full cycle. So what do I mean there? Well, what I mean is sine of x repeats itself. It keeps repeating itself, the sine wave. It starts at 0, and then it goes up, goes to 0 again, goes down to -1, and then comes down to here, 2 pi. And then after 2 pi, it's going to continue, but what it's going to do is it's going to do something different. Or it's going to repeat itself. It's not going to do anything new, I should say. It's just going to repeat itself. So it's going to go up, then come back down. So one full cycle is what we call a period. So how long will a graph's period be? Sometimes it'll be 2 pi, sometimes it'll be shorter, sometimes it'll be longer. We're going to see some graphs today where sine graph will look like that. It's over by pi. Some of them will extend longer. Some of them will extend longer. Okay? What causes that? We'll talk about that later. But how to find the period, how to find how long it takes to go through one full cycle is 2 pi divided by b. So b is here. Okay? So b is goes with period. So for this guy, b is just 1 because there's just a 1 in front. So it's 2 pi divided by 1, which is 2 pi. So this guy here, which we already know, sine of x, it takes 2 pi to go through one full period. Okay, that's what we call, the two terms, amplitude and period. So for any graphs that you're graphing with sine, so any graphs that say sine, you're going to have some parts to it. Some of the parts you might have, some of the parts you might not have. So we talked about it a little before, A. A is the, sometimes these will be capitalized, sometimes these will be just lowercase. It doesn't matter, it's the same thing. So A is the amplitude. That's how high and how low the graph goes. So another word we've used before is stretch or compress. Okay, so that's going to affect that. B is going to affect what's called the period or the cycle. So if B is a big number, the bigger B is, the faster the cycle goes. The shorter the cycle is, which means it's going to go through faster. The smaller, it's going to get bigger, or the cycle is going to get longer. So we're going to do some problems with that. So that's what that controls. C is what we call a phase shift. C and D are actually called phase shifts. Phase shifts are C is going to move it right or left. D is going to determine up or down. Okay? So those are kind of similar to what we've talked about in the past. If D is for example, if D is positive 3, that means the whole graph is going to shift up 3 units. If it says minus 2, that means we're going to shift to the right 2. Because remember, C lies, this guy tells the truth. So if it's a minus C, that means we're going to move to the right. If it's a plus D, that means we're going to move up. If it's a plus C, we move to the left. And if it's a minus D, we move down. Okay? So that's what's going to happen. Okay, so for the first one. Okay, example number 1. So in red over here, I've already graphed the parent graph. The parent graph is y equals sine of x, the one we graphed in the notes last time. So that's the parent graph. Okay, so this one is the one I'm going to graph now. All right, so the first thing I got to do is find the amplitude. Well, amplitude is absolute value of A. And this guy has an absolute value of 5, so that means 5. So that means it's going to go up to 5. So that means when I eventually graph this guy, 2, 3, 4, 5, it's going to go up to 5 and down to negative 5. So it's going to stretch. It's going to have a stretch there. Okay, so the next thing is B. B is the period or the cycle. Okay, so here, 2 pi over B. So let's see, 2 pi, so period. So let's figure out what the period's going to be. 2 pi over B. B in this case is just 1. So it's 2 pi. So it's still going to take 2 pi to finish one cycle. Okay, so it's not going to be shortened or it's not going to be extended. Okay, there is no phase shift here. There's no phase shift because we don't have x minus or plus anything and then nothing after that. So those are just 0. Okay, so another way of writing it would be that's kind of like the same thing. So there's not moving left or right, not moving up or down. Okay, so pretty much the only thing that's going to happen is it's going to be stretched by a factor of 5. So every point is going to stretch by a factor of 5. So the x is going to stay the same, the y is going to change. Okay, so let me change color here. So 0, 0 is going to stay 0, 0. But here, instead of being at 1, this point's going to be at 5. This one's going to stay at 0. This one's going to go to negative 5, and this one's going to stay at 0. So the y is the only one that changed. That's what amplitude does. Amplitude changes the y value. So now when this graph goes, it's going to go up to 5, back down to negative 5 through 0, and stop here. So that's what the graph is going to look like here in blue. Okay, so you see the amplitude goes up to 5, down to negative 5. It still finishes one full cycle from 0 to 2 pi. That's why the period was 2 pi. And there was no shift up, down, left, or right. Okay, so for example number 2. So example number 2, we have y equals 2 sine of 2x. Okay, so it's still sine. So again, in red, I've done the parent graph, y equals sine of x. Goes up 1 and down negative 1. Okay, so the amplitude is 2, or the absolute value of 2, which is just positive 2. Okay, so it's going to have an amplitude of 2. Means it's going to go up to 2 and down to negative 2. The period, see we have a b term now. So we're going to have 2 pi divided by 2, which makes it pi. That means this whole thing is going to be over by pi. See, the red one goes from 0 to 2 pi. That's how long it takes for it to be done. But this guy is going to be over by pi, so it's going to shorten the time by half. So really, on the right side, we'll be able to graph 2 cycles. Okay, so here we go. Okay, so, all right, so amplitude is 2. So I'm going to move up every dot 2. Okay, but the problem here is the period is not 2 pi, it's half. So what I got to do is horizontally shrink it. So that means normally a normal graph has a 2 pi period, but our graph has a pi period. So that means all the x's will be shrunken in half. So all of the x's are going to move left. They're going to have half of the size. So this guy right here, this dot right here, which used to be at pi over 2, is now going to be at pi over 4. Okay. This dot right here, which used to be at pi, is now going to be at pi over 2 because it's half as long now. So let me erase this. This dot here is going to be here. And the last dot is going to be here. This whole graph is going to be over by pi over 2. Okay, so let me finish graphing it. Up, down, up, one whole cycle. Whereas the other graph was up, down, up. So you see how it's got the same shape. The only difference is it has an amplitude of 2, so it's got a little bit of stretch, and the period is shorter so that it finishes faster. Okay, so example number 3. Okay, so A. So the amplitude is A. So we got a 1 in front, so that means our amplitude is 1, so it means it's not going to be vertically stretched or compressed at all. Our period is also going to be the same because B is still 1. So it's going to go a full cycle of 2 pi. This one, though, where we have some differences, is this one has a phase shift. It has a phase shift. How do we know that? Because right here, it's got a C. It doesn't have a D. So it doesn't have a D. This one doesn't have a D, so it's plus 0 in the end. So it's not going to move up or down. But that minus means it's going to move right pi over 2 units. So the only difference between our new graph and the graph that I already have for sine of x is that every dot you see will be shifted to the right pi over 2 units. Okay? So 0, 0, 0 will not be there anymore. It's going to shift pi over 2 units here. Pi over 2 comma 1 is going to shift pi over 2 units. Pi 0 is going to move here, and then this one's going to move here, and we're going to kind of be off the track a little bit here, right there. So now we're not starting at 0, 0 anymore. We're starting at pi over 2, 0. So our new graph is going to go here. It's going to have the same shape. It's going to look very, very similar to what the red one did. Let me put the red one back in. It just got shifted to the right pi over 2 units because of this guy here. Okay?